Hello everybody, welcome to the webinar. Today we'll be covering the topic SAS to R migration. Today's agenda is why R, the motivation behind choosing R, which is a statistical programming language. We'll be going through brief introduction of SAS and R. They both are statistical programming language, but we will get into the differentiators as well as the commonality between both the languages. SAS product by tiers. Here I'll give you a glimpse of the vast product suites that is offered by SAS. In particular, we are only focusing for the business intelligence and analytic solution that SAS has. Then next we'll be talking about the SAS Metadata Server. We'll be showing how we can leverage the metadata to quantify and automate the migration. Our approach for the SAS to R migration, there is like a factory model that I want to talk about. And then at the end, we'll be walking through workload, some of the workload conversions, where we will have a side-by-side comparison between SAS code as well as the R code, an equivalent R code for the same. R, which is an open source statistical programming language, is now integrated within SQL Server 2016. By what it means is when you install SQL Server and you select R as a feature, it basically installs all the extensions within it, and there is an R service running. So now you can run an R script in SQL Server environment, and it's all integrated with T-SQL. Microsoft is pushing for advanced analytics by leveraging R, and SQL Server is now has all this memory optimization, scaling in memory and parallelism. So the idea is to leverage that with all the functionality that R has to provide. The one big advantage of using R here is into SQL Server environment is not having to move the data. So in SQL Server, we already have this huge data set, and now we want to do this advanced analytics, and it's all there. We don't have to move data to an R engine, which is outside SQL Server. So it's all integrated within one server. And the beauty about it is it's all T-SQL. On the right, if you see, there is this T-SQL code that you have this R script written by a data scientist or statistician. You just put that R script in your T-SQL code, and you're gonna use the data that's in the SQL Server, and then use this statistical functions provided by R. In addition to R service capability in SQL Server 2016, Microsoft also has this standalone R server. So where it's leveraging the open source R, packaging it with the proprietary Microsoft parallelism and in-memory optimization. And there is this Microsoft R client, which you can connect to the Microsoft standalone R server, and R server could be on Windows, Teradata, Hadoop, on cloud. So R has a huge repository for data mining algorithms like C 5.0, K-means, a priori, EM, PageRank, KNN, naive Bayes, CART, also the statistical functions like density, cumulative distribution, quantile function, logistic regressions, Poisson, binomial. So they are all available in S as well. But so basically, we are trying to migrate from one statistical programming language to the other one. And just as it's now integrated within SQL Server 2016, if an enterprise already has their data on SQL Server, there is no reason to go out of that environment and just leverage this for the advanced analytics. Also, the point to be noted here is it's an enterprise feature. So as long as you have an enterprise version of SQL Server, it's just an additional feature that you need to install. So if you see on the diagram, it's the simplified version here is from the application, you call the stored procedure on a SQL server, which has the R script, and then it outputs the data back to the application. So it's all transparent. SQL Server takes care of it and then returns back the result. SAS and R, the commonality and the differentiators. So when we talk about the commonalities, they both are fourth generation statistical programming language. SAS was introduced in 1976, R in 1993. And among the differentiators, SAS is proprietary versus R is an open source. Also, the way the programming style in SAS, it's more of a procedural, step by step, and R is more of a object-oriented or functions. Also in SAS, the computation happens row by row. The execution happens row by row. So let's say you have an aggregate function of of a particular column, and you have 5 rows. It's going to aggregate one at a time and then go to the next row and then add that column. Versus in R, there is a lot of parallelism happening. So SAS is more IO intensive because it's doing a lot of reads and back and forth and writing back the data, and then R is more of a memory intensive because it's trying to do a lot of computation at once. Also in SAS, a data set is composed of variables and observation. You can think of variables as the columns and observation as the row. Versus in R, it's all table, like the structure that we are kind of used to. The data step. So in SAS, if you look at the SAS code, it comprises of a data step and a procedure step. So the data set comprises of statements that read data, creates new data sets or variables, modifies data sets. So everything to do with data. It begins with data statement. So there is a syntax used data. That means that is a data step. You can read the data, modify the data, delete the data. And procedure comprises of statement that can perform statistical analysis, create and print report. It begins with the syntax proc, P-R-O-C, and it performs specific analysis or functions, produces output as result or report. So when we think of SAS code and R, it's not a one-to-one conversion. So a 5-line code might translate it to 1-line code or vice versa. And also for a complex SAS code, you might have to review the implementation documents. It's the same idea, right? When you have a data mining algorithm in SAS and in R, you might have to do a few more tests to make sure the result sets are actual, they make sense, or it's accurate or as expected within SAS. SAS products by tier. This image I've gotten from their website, where we have grouped all the products within their tier. So within data source, it could be SAS data set we just discussed, the rows and the variables, the way it stores the data. It could be an OLAP cube. It could be a third-party data store or an ERP system. For the SAS server, you have the SAS Metadata Server, which we're going to deep dive into. Then there is a workspace server, OLAP server, store process server. So a lot of processing happening within that server layer. And then this middle tier product suites that they have, and then there are clients. So the one we are working on right now, or we are trying to migrate, is the business intelligence and analytics piece within the middle tier, which comes with the metadata server. And for the migration, we want to leverage the metadata content. With SAS 9 and up, they have introduced SAS Metadata Server. So for the business intelligence, what it means is for the business intelligence and analytics solutions, all the objects are stored into the repository, the metadata repository. So when we take on to this migration project, the two key questions that we need to answer prior to starting the work is how many and what are we migrating? So to quantify this, there are three ways to query the metadata repository and get the answer before we start actual coding. Also, it helps us to understand the level of complexity that we are getting on. So out of the three ways, the first way does not need any programming language. So we are using this management console to which provides us the data. It also comes with a set of reports for the metadata. So basically in the first method, we will use the front-end interface provided the SAS management console. The second and the third method are a little bit more advanced, and programmer can then leverage the data step functions that is provided. So in the second method, we use SAS data step functions, which allows us to query metadata from the standard DMS environment. Within a metadata server, everything is stored as metadata objects. So once we understand that everything is an object, and each object has URI, which is unique resource identifier. So you can uniquely identify each object. And each metadata comprises of a property, attribute, and association. And there are methods and functions basically to access those objects. So that is get object, get attribute, get association. So when association describes the relationships that one object can have with other. For example, the relationship between a table and its column. Let's say if you are accessing the physical table metadata, you can use an association called columns to retrieve their variable names. And if you are in the column metadata, you can use the table association to retrieve the name of the table. So, and there are also other things that you can get out of the metadata repository, like the user counts, the active connections. At Scalability Experts, with our experience of working on projects with SAS as well as R, from the knowledge base, we have built a workload library. So there are commonly used routines that are used for SAS. So we have a equivalent translation in R. Those are like 70% time those routines are used in any analytical routines. So the approach here is we collect the data from the metadata server by interrogating the metadata server and get all the analytical routines. Once we get the analytical routines, we can quantify the work, we can understand the complexity of the work that needs to be migrated. So then we bucket it. We kind of identify and analyze the workloads and we bucket them. And once we have that list ready, we start the actual work. We pick one category at a time. 70% of the time, we're going to find those workloads in the library that we have built. And we find that equivalent snippet of that SAS code into R. And then that's the automation piece. Again, I understand that it's not going to be apples to apple comparison. Both are different programming languages. They both use different analytical routines at times. So we have to find equivalent translation. So there is some level of coding involved. So once we have those pieces into place in that analytical routines for R, the missing piece is where we need to code. At times we won't need that coding piece, but let's say if we need it, and that's where the functional testing starts. After that, also as part of the migration, what we do is in any approach, be it SAS to R or Informatica to SSIS, what we do is we compare the input to the output. So we have the standard test results. So that's part of the functional testing. So we provide the input and get the output. So a lot of data mining algorithm, let's say an analytical routine, it's using. So to make sure that those input spits out the same result set on the data that we are using is done right on the R as well. So once we get through the functional testing, we do a system testing where we test multiple routines together to come up with the final predictive analytic or whatever we are trying to do here, or build a report, and then we deploy. So here are some of the examples for the workload library that we have in place. So this workload library is built by statistician on staff, data scientists, and programmers. Some of the commonly used routines could be a data row validation, let's say data quality validation, performance benchmark, parallel execution plans, how we do it in SAS versus in R, and some of the algorithm translation from SAS to R. So those are all collected together, put it into a workload library. So here, as we see in the list, we are trying to read a CSV file. We see an equivalent SAS query for that. Here, data, as I was breaking it down earlier, there is a data step and there is a procedure step. So in data step, we are trying to access the table and then read the file. And similarly in the R query, that's the syntax for it. And for the merging data, it's more of a analytical routine, let's say, like it's more logic application. Then here it's doing proc. This is a procedure step. It's sorting the data first on the table 1, then it's sorting the data on table 2. By A is the column. So it's trying to sort by A. And then it's trying to merge table 1 and table 2 by A. And it's giving the command run, which is like submitting the job. And an equivalent R, as you see, it's much more simpler because there is a function. So everything is function in R. So, and it leverages parallelism a lot. So R is great. Yes, it is CPU intensive, but at the same time, the coding is much simpler. So you see here, there is a merge function where you have a table 1, table 2. You are trying to merge by A, and then all is equal to true. So there is some parameters where you need to specify whether you want duplicates or not. And that's the parameter where it says that you need everything to be merged and not just the intersection. So all is equal to true means you need everything, all the results set from table 1 as well as the results set from table 2. Then there is this logistic regression, which is commonly used. You have this proc logistic, and then you build a data model, and then you build a model in SAS query, versus there is a function where you use the binomial property of that. So here GLM is the generalized linear model. The parameter it accepts is the first one is the formula. So we have this y tilde x1, x2, x3. So that's the formula here. And in family, right now we are choosing binomial, but it could be Gaussian or Poisson, Cauchy. So there are various parameters that could be passed here. And then the final, we have the data, which data it needs to be used for that function. So there's this another routine for nonlinear optimization, finding a square value. So you see that we have this library where we have this commonly used process, and we have a translation into our query. So once we identify, so when we do this analysis, right, a particular routine could be a composite, or I mean, most probably it will be a composite of it reading a file, merging a data, and then doing some analytical algorithm, and then spitting out the results. So what we will do as part of the analysis is we'll figure out that this particular routine translated into workload library index 1, 7, 9, 15. And that's what it comprises of in that order. So there is some engine automation done. And then there is this manual intervention where we understand it, or kind of when we put it together, we kind of have a guidelines, or as I said earlier, factory model that we have this repetitive, consistent model that once we finally migrate it, doesn't matter if this is a programmer A or a programmer B, we're going to see a pretty similar result. So to go over some of the more routines, here I've, as an example, showed fuzzy matching, range function, reading URL, entering data. So in fuzzy match in SAS query, it's kind of a join between, let's say, two table set, data set, which is SAS help. It comes with a sample data set. So SAS help.class, there is a, and then there is another class B. We're just doing a join here to find if soundx name one. So that's the soundx function within SAS. So now we are trying to find an equivalent in R query where we have this two data set. We're trying to find a match on particular one. So that's what the R query translation would be. So it's like looping through and binding and figuring out which one it finds a match. Similarly, on the range function, let's say we have a high, medium, and low. Similarly, we have a translation in R as well. Reading URL the same way, and then entering data is also pretty simplified in R. This brings us to the end of the webinar. Uh, Thank you very much for your time.